Every programmer eventually writes a class hierarchy they regret. You start clean, animal, then bird, then eagle. But then a new requirement arrives, a flying fish. It can swim and it can fly. Which class does it extend? Bird, fish, both. You have just walked into the diamond problem. And this is not a rare edge case. It is the inevitable destination of deep inheritance hierarchies. Today we are going to pull that hierarchy apart and show you a better way to think about object design. The principle is called composition over inheritance, and it has been the right answer since 1994. You can recognize an inheritance problem by three symptoms. First, the diamond problem. Two parent classes define a method with the same name and the compiler has to pick one. In C++, you get undefined behavior. In Java, you get a compilation error. Second is the gorilla banana problem. You wanted a banana. You got the gorilla holding the banana and the entire jungle it lives in. Inheritance forces you to pull in every method the parent ever defined, whether you need it or not. Third is the fragile base class. Any change to a parent class, even a private field rename, can silently break every subclass downstream. The alternative is composition. Instead of asking what a class is, you ask what it has. A duck does not extend bird. A duck has a flyable behavior, a swimmable behavior, and a walkable behavior. Each of those behaviors is a small self-contained interface with a single method. Penguin is not a special broken bird that throws an exception on fly. Penguin has swimmable and walkable and simply never mentions flyable at all. Flying fish has flyable and swimmable. Zero changes to any existing class. You just wired together two behaviors that already existed. This is the HASA model versus the ISA model, and HASA wins almost every time. Code difference is stark. On the inheritance side, you write class penguin extends bird, then override fly to throw an unsupported operation exception. That exception is a runtime declaration that the ISA relationship was a lie. On the composition side, you define a flyable object with a fly method, a swimmable object with a swim method, and then a penguin is just the spread of swimmable and walkable. No hierarchy, no lies. When the flying fish requirement arrives, you write 3 lines. Spread flyable, spread swimmable, done. The inheritance version requires you to rethink the entire class tree. Composition is also the mechanical reason the solid principles work in practice. Single responsibility, each behavior module does exactly one thing. Open-closed, you added flying fish without touching bird, animal, or any class that already existed. The system is open for extension and closed for modification. Liskov substitution, penguin never claims to support fly, so no substitution can fail. Dependency inversion, your duck class depends on the flyable interface, not on a concrete implementation, so you can swap behaviors at runtime or inject a mock in tests. Every solid rule becomes straightforward when you decompose behavior into interfaces. Once you recognize composition, you see it everywhere in the design patterns canon. The strategy pattern replaces template method. Instead of overriding a method in a subclass, you inject a strategy object. The context calls strategy, sort, and does not care whether that is a quick sort or a merge sort. The decorator pattern wraps a logger around a cache around a database connection. Each layer holds a reference to the next. No inheritance at all. And then there is the entity component system used by Unity, Unreal, and every serious game engine. An entity is just an integer ID. A component is just data. You attach a flyable component to any entity without any class rewrite. Composition at scale. Beyond those 4 patterns, one more example stands out: React hooks. Before hooks, React used class components with lifecycle methods. Teams used higher-order components and render props to share logic, both inheritance-flavored approaches. Hooks replaced all of that with plain functions. Use state, use effect, use query. You compose them inside any function component. No class, no hierarchy, no mixin conflicts. When the React team explained why they replaced mixins, they used the exact same language as the Gang of 4, favor composition. 30 years apart, same answer. So when should you still use inheritance? 3 cases justify it. True is a relationships with no exceptions. Integer really is a number and no subclass would ever need to stub out a method. Stable sealed hierarchies like standard library types frozen for 20 years. And framework extension points. Extending Android Activity or UI View Controller is appropriate because those classes were designed as extension points. The simple test is this: would any future subclass ever need to override a method and leave it empty or throw an exception just to avoid what the parent demands? If yes, the is-a relationship is a lie. Switch to composition before that code ships. Let us bring it together. Inheritance models identity. Composition models capability. The moment you model capabilities, is-a breaks. You want to say this object can fly, not this object is a thing that happens to fly. Go has no inheritance at all, just interfaces and struct embedding. Rust has traits. Both languages reach the same conclusion independently. A class hierarchy is a liability that composition avoids entirely. The Gang of 4 said favor composition over inheritance in 1994. React hooks proved it again in 2018. Every time the industry has tried to solve code reuse with inheritance, it has eventually retreated to composition. Now you know why. Thanks for watching.